Good afternoon, everyone, and thank you for attending our Dealing with Component Shortages That Impact Battery Designs webinar. My name is Ed McMahon, the CEO here at Epic. Before we go ahead and get started, I wanted to let you all know that you'll be muted during the presentation. So if you have any questions as we move along, go ahead and enter them into the questions panel located in the webinar control panel, and we'll try to get to them all at the end of the presentation. If we don't have enough time to get to all the questions, we'll make sure that we'll reply back to you via email. Also, we're going to go ahead and record this webinar, and we'll be posting both the recording and the slides on our website and YouTube channel. Our presenter today is Randy Ibrahim. Randy is our battery technology expert. He's been active within the battery and battery charger industry since 1996. With over 30 years of experience in military, medical, industrial, and the consumer high volume industries, he's got a unique advantage when qualifying battery designs for use in his batteries. His work includes pioneering the development of custom safety circuits, battery chargers for different types of applications and chemistries. And as a result, Randy's received numerous patents in his area of work and has written numerous articles for industry trade publications. And this webinar today we brought to you because Randy's also spent a good portion of the last year and a half trying to pull rabbits out of his hat when it comes to dealing with component shortages that we're all dealing with today. So without further ado, I'll pass it over to Randy.
All right, thank you, Ed. Appreciate it, and also I appreciate the opportunity to go over this very important topic. And unlike what the title says here, this now, as you know, doesn't only impact battery pack designs, but also our end customers are also suffering from the same shortages that we are. So we thought it was very timely to bring this type of presentation to the forefront and in front of everybody. Today, we'd like to cover some of the items here. First, how to find parts and be competitive in these times of component shortages. First of all, we'd like to find the original part. This is always much more desirable than doing anything else. So to do this, normally we would consider using another contract manufacturer to quote the boards. This is very important, which we'll cover. Also, it's very important to simplify parts, numbers on BOMs, and also be able to expand the BOMs by simplifying part numbers. And also kind of get out of your shell, start looking around at your distributor base, maybe expand it and look worldwide, not just stateside. And then we're going to cover if all those original parts are not available, obviously the second best option here is to find substitution parts. A lot of times we can just look at perhaps a different grade component. If possible, we'll review the details of that and also adjust perhaps your design to accept different type of parts, different shape. They could even be original or substitution parts, but sometimes the form factor is all you need to do to get you off and running and produce product. And then last, we go through the painful parts of redesign, some of the ramifications that can present itself, how to work around single source ICs with long lead times, and how to make new and future designs much more resilient to the supply chain issues that we see today, so it doesn't happen again. And also, we like to cover some of the methods that we use to minimize or eliminate the use of these single source parts. And also, as I mentioned earlier, is the methods of perhaps layouts and change your boards a little bit to allow flexibility in component selection and preventing redesigns in the future as well. And lastly, use a firmware to perhaps reduce dependencies on sole source parts, especially if you have to keep that firmware on board anyway. So here's the scenario. Here you have a supplier or contract manufacturing partners and they're giving you all that bad news, long lead times. What's someone's to do in this type of situation here? First off, look and find another contract manufacturer to quote your boards. A lot of people aren't aware, but some of the larger CMs have BOM reserves, and they can reallocate some of these parts and sell them, so use the parts from other customers. And also some of the CMs have these CM relationships to be able to source parts for you. And obviously, these parts you will not find on any distributor's website. These are all part of the CM. The large ones have this. Unfortunately, a lot of these parts pertain to resistors, capacitors. Some parts are multi-sourced with different manufacturers. Sometimes you might get very, very lucky and have some really oddball corner part that you need, but unlikely. But it's definitely worthwhile to try there. So here you're seeing can't find parts, and you tried and to no avail. So what are we to do now? It's it's time to roll up our sleeves and get a little more serious about this. So we need to kind of deep dive here, and still sticking with the original parts. And there's a number of things that we need to look at closely. For instance, we need to expand that distributor base. A lot of people are just used to using a handful of distributors that they've used all their life, and it's time to look outside that box a little bit and kind of look in the corners of the world to do that. So you need to do a more thorough research, and one tool I use at findchips.com. It works quite well. Finds a lot of different distributors that you may not even be aware of. There's parts in Japan or Taiwan, that you might be able to capture and bring them in. So definitely start looking at all the nooks and crannies around the world, and these tech tools can definitely help you do that. Of course, we all are tempted to use brokers, and we do on occasion, reputable ones at that. But you really have to be careful. The counterfeit parts, as everyone knows, can be an issue sometimes. The one thing that's important here is a lot of people don't look at this because a lot of times engineering will go ahead, and I'm guilty of this as charged here. A lot of times we'll do a simple bill of material, pull together some parts, and what we want to make sure is that we don't capture the packaging within the part number. A good example here is a TI part, a fuel gauge. We use a lot of them, and it's the BQ34Z100 PW. And a lot of times we'll put on the data sheet, or the BOM, I should say, just the PW part. But if you look closely, the PW part down below in this lower left-hand corner, it essentially signifies the tube. So your parts will come in a tube, and everything's fine. However, if you put the R in the back, R stands for real. And so it's really important that you expand your BOM and include both these part numbers. That way your purchasing department, your procurement department can have full access, because if they're only looking for one of these two, the PW or the PWR, they might miss a whole lot of parts out there that are available in just a different packaging. It's the exact same part, different packaging. So really look at your BOMs closely and start breaking out areas that are really kind of crippling you in finding parts. Let's say all the possibilities of finding the original part have been exhausted. You went through everything, all the different methods that we just outlined. Now, what's the next step in the process here? Obviously, the next step would be to look for substitution parts. And substitution parts are not the original part. They are close. And if you look at almost all designs out there, I can't think of one that isn't, but only a very small handful of parts usually have very tight tolerances or a single source. But most of the other parts in the design may have very loose tolerances and can be substituted easily. A good example of this would be like bulk capacitors, filter resistors, what have you. A lot of times at the end of our designs, we'll look at all the parts we have, and our BOM's pretty large, and we try to group down, because obviously there's cost savings if you have least amount of reels and parts on your pick and place machines while these are being manufactured. So we'll look at, if we have a component really close to 10K, we have a lot of 10K resistors on board, we'll go ahead and change these part values if we can, because they have a 20, 30, 50% tolerance. We'll bring them down into the 10K level and just build up those parts, and perhaps get rid of a reel or two. And the same scenario here, you can actually break that apart, and let's say that a 10K isn't available, but a 10.1K is readily available. You might want to switch your parts over to that other oddball part and be able to get your parts in. But obviously, any substitution parts that you go, the path you go down with the substituting parts, you need to work extremely closely with your engineering department this is not something that the purchasing department just does and blindly, because that can get you in a lot of trouble. But you'd be surprised when working with the engineers that a lot of them will say, oh yeah, half of these, no big deal. We can swap them out and work within reels that you can get. The other bullet here is to identify substitution parts. We use Silicone Expert a fair amount, and there's other websites that work as well. And you have to use a little caution that they're really good at getting you close. And they're really good at FETs and what have you. They'll get you close where you want to go. But working with your engineering team, that close may not be close enough, because obviously there's usually 2 or 3 different parameters that are extremely important in your particular application, where those other parameters in other people's application may be different. However, when you look at what this website provides, you need to really compare those specific parameters, make sure they're within your needs and that the part will actually work. Even though they're saying it will work, it may not. So here you're able to find, let's say, most of the original parts, and you got a handful of substitutes using the first couple techniques that we covered. But you still can't find those really long lead item parts on your BOM. What are we to do now? Obviously you can't produce a product if even one part is missing. So it's very important to have a complete BOM that you can purchase. The first thing we look at is different grade components. A lot of people don't see this. It's kind of tucked in the corners of a lot of designs, but work with the engineering team, confirm that your design can accept different grade components. The two highest ones, I guess the low-hanging fruit would be the speed and temperature grades. So a good question to ask yourself is, hey, does my product run at a low speed, but maybe higher grade parts are called out, or maybe the lower grade part is called out, but higher grade parts are available? And if you look over to the right, for the temperature one, you have I and E, so your part number changes a little bit, but those would be really good to add to your substitution or alternative parts usage list. And so you can capture those, and it gives your purchasing department a much greater chance of being able to fulfill the requirements of meeting the needs of producing your product. Down here, the temperature also, that's the same thing. Is your product used indoors? But perhaps your design does call out the extended temperature range or industrial military parts. Maybe that was an accident, what have you, or vice versa. Maybe you're using the right, room temperature part, but don't miss out on the opportunity to call out or use those high temperature range parts, because they're just as functional, they're just as good, and there might be plenty of them. You just aren't aware of it. So it's really important to look at the difference of the different grade parts that you are consuming. So let's say that you have no luck in finding the correct part. You're getting down this list, and now, of course, we went from easiest to most painful. Now we're entering painful category, and this is where it does become a little bit more painful. Something to look at. This actually requires slight design changes, not full redesign, but you have to modify your design, which can, depending on your industry, can or cannot be something that's possible. But something to look at is adjust your design to accept different shape, original and substitution parts. A lot of parts come in different form factors, different footprints, everything. So you can open up your whole BOM if you can accept all these different type of parts that fit differently on your board. And then you can design multiple footprints for the same part and provide that substitution flexibility that you're looking for. And you want to separate these put separate footprints next to each other, or perhaps incorporate them on top of each other whenever possible. And a really good example of this is one of our boards. If you look at the 3 pictures shown down below here, these are 3 totally different parts, totally different footprints, and they all fit on the same board. And so this is by design, where you can substitute parts different when you can't get a part. You can use a different one. The caution here is sometimes you need to adjust your essentially your solder paste screening process to adjust the amount of solder paste that's deposited. For instance, on this left picture here, we have a lot of bridging. In this case, it makes no difference because this is all the drain of a FET, so they're all a common node anyway. But in order to pass some of the soldering standards that are out there, you would have to adjust your solder pace, reduce it some in order not to get that bridging and be able to pass some of the regulatory requirements. So, but those are really inexpensive, easy changes to do on the fly. It doesn't take a big design change, and the basic functionality of your circuit remains the same. One thing you do want to make note of here is to pay extremely close attention to EMI issues and compliance when making any changes in the clocking switching portions, for instance, in the power supply. And also you want to look at the high voltage areas. There's also these isolation gap requirements. You don't want to close those up. UL will slap your hand for sure, or worse. And also impedance control designs, RF designs. So, you just can't blindly go through and do this, but because it will actually change your actual design parameters. But it is a great opportunity. For instance, these parts are all in the DC portion of a design. They have no impact whatsoever on any regulatory. So it's definitely a good method and something to definitely consider. So here we are, and the part you need cannot be found. And there's a lot at stake, even different footprints, whatever, you cannot find the part. So we need to get this part delivered. There's a lot at stake. And what can we do? Okay, we have a couple last resort options. And the first one, I know everybody's cringing right now, is just use scrap parts. And we're not talking about junk parts, we're talking about scrap parts, big difference. Depending on your market, of course, your application, type of part, the quantities in play, customer tolerance, and also the customer's desperation level, or stockholders' desperation level, it is possible to use parts from factory scrap boards and other scrap sources. Of course, this will not work for certain types of parts or products and should only be done after full disclosure to the customer of all the risks involved. And after factoring in many variables, only the customer can make the final decision to go this route. And of course, if you're using used parts, and depending what part it is and the complexity, additional manufacturing, testing, or screening may be required than what would be normally done on your product in the production environment. So the last resort, option 2, kind of call this the nuclear option, is a full redesign. First of all, you have to ask yourself, before you go down this ugly path, is you need to ask yourself a question, is like, what assurance do you have that these new ICs that you're going to be using in this new redesign are going to be available? They're there in stock today, but this is a long process, and are they going to be in stock tomorrow? So there may have to be an upfront commitment, especially in today's environment with part shortages and parts flying off the shelves fairly quickly. You may have to make that commitment to stockpile some of these parts ahead of time, especially the low risk ones that will be in the design. Obviously, that depends on a lot of factors, and we won't go through all those, but it's something to consider that you do stockpile, at least to get through regulatory testing and maybe the initial production builds, and then maybe cross your fingers after that. But it's something to seriously consider. Second, redesigning even the most simple circuit is never a trivial process, even if it's, even though in theory it's so. And especially I'm guilty of it. A lot of engineers kind of hand wave and think it's really easy. But when you start digging down, what's really involved here is there are a lot of layout issues. For instance, if you're starting to use different ICs, maybe the final solution is more of them, more parts. Can they fit on that original board, or do you have to use the other side? Does the product grow, what have you? If you're redesigning a switcher, EMI considerations, all that needs to be taken into account. Packaging, not just the product, but what it goes into, overpack, what have you. Those all need to be redesigned potentially. And then qualification. If we're talking about a medical product, this might be more painful because all of a sudden, here we are, how in depth is the qualification process? Do you have to go back from ground zero? That could take years. And then if you're talking about maybe a year-long, 52-week-long lead time on some ICs, maybe those long lead times don't look so bad compared to this option. So you really have to look at this closely. And also, there are normally, with all designs, and I have a lot of scars to prove it, there's unpleasant surprises. And even with the most simple redesigns, it's mind-boggling what can creep up and how that can be affected. So here, I know it's a sunny day. Hopefully all the parts were found in a reasonable amount of time, and you're off and running, delivering product, and life is good. But now in the back of your mind, you're thinking, wow, that was a very painful process that we went through, and how is it possible to avoid this in the future? So looking forward for new designs to make them more resilient to the supply chain issues, a number of things can be done. First, try to reduce the use of highly integrated IC solutions. And in general, they allow designers to add a lot of functions and features. Sometimes, they may not always be of great value to the end user, but they normally just add a lot of bells and whistles. So it's really kind of in your best interest to limit their use whenever possible. But if you do need a lot of this functionality, but you don't want to get locked into a sole source part and have no other options, it is possible here to substitute the highly integrated ICs with simple embedded controllers with code that's written at a high enough level that can be compiled to different manufacturers' controllers. And this is still a painful process. A lot of times it requires a board spin and getting the headers just right on your compilers. And there's still a fair amount of testing, but it gives you a plan B, C, and D, where if you look at only using that highly integrated IC, you have plan A and no other recourse. If that manufacturer gives you an 80-week lead time, you're dead in the water. Where the second option, at least there's hope. You can move forward. Another method is try designing in very common parts that many manufacturers produce. A good example here is that BSS 138. A lot of people know this part. It's a workhorse. It's a simple N-channel FET. We use it a lot of times just for FET switches. If you use it in that type of application, all these manufacturers work just fine. You just go ahead and pop it in. Any manufacturer will work if it's a simple switch. Same with this quad op amp, the LM324. We use this in a lot of battery chargers, especially custom ones when we have a lot of multiple parallel batteries and we have to load shed all the current between them. This is a great workhorse. It's been around forever. And in those applications, we can go ahead and use any of those manufacturers and it'll work just fine. Where you have to be extremely cautious when designing in these type of parts is don't be fooled. Every manufacturer has a slightly different twist to the data sheet. The main parts that make the part a general family always remain the same. That's not an issue if you use it down the mainstream parameters that the part is designed for. But let's say that this BSS 138 is used not in the saturated region or depleted region. It is used more in a linear region. Now all of a sudden gate capacitance might be a factor, gate thresholds might be a factor, the Miller plateau, and you name it, all these things can start coming into play. And I guarantee every single one of these data sheets from every one of these manufacturers will have slightly different parameters for each one of those areas. So if you are using a linear region and not a straight on-off type scenario, then you really need to look closely at these parts. Another item to look at is make sure you use common packages to avoid, manufacturer custom packages. Make sure that you're definitely looking at ways that you can have the multiple sources all use the same package so you don't have to do board spins. And I reached out to one of my friends. He's in a totally different industry, much smarter than I am. His ICs he uses are usually around $15,000 to $20,000 each. I mean, you don't want to burn one of those up. That can get rather costly. But I asked him, how he's dealing with it. And the one he said is he actually has a whole engineering team, and he says his engineers are working full time on just substituting parts. That's all their life is right now. They're not even working on a new product. And one thing, an idea he came up with is they use a lot of times they'll call out 2 core ARM processors instead of a single core. They only need a single, but they just don't use the other core. And it kind of seems counterintuitive, but it makes a lot of sense. They're a lot more readily available because they cost more and they have availability. But when you're looking at a single product costing a couple $100,000, this is just pennies on the dollar. So kind of makes sense to have your product capable of using both. It might take 2 board spins. I'm not as familiar with these ARM processors, but kind of think about maybe using the more complex part and just not using every feature on it. Kind of goes against what I said at the beginning, but this is some input I received and kind of makes sense, the route that they're taking. And also, a lot of people just use ICs at random. Obviously some of the products look better when you have an IC because of digital displays, what have you. But I guarantee this little kitchen timer here is still in production and you can buy it. Where maybe some of these similar products done digitally may not be available because of all the shortages of parts. Your plastics, your UL can call a number of different plastics, silk screening. There's a number of manufacturers that can make springs. So there's a good chance you can reach out and always find parts for a very simple product. Sometimes, it's really important, the old KISS principle, keep it sweet and simple, applies. And I'll reiterate this again. It doesn't only apply to redesigns, but new designs always look at a way out. Have multiple footprints. I call them insurance policies. We put them in all the time in a lot of our designs when we have room. Really important. And so, in fact, this particular product has additional pads on the back side of the board that we can use for even more strange form factors. So we put these in routinely, and very important to consider that. And it should be part of your design verification process with new design reviews to make sure that this is being implemented. And then lastly here, you can use firmware to reduce some dependencies on sole source parts. This probably applies to some of the older designs more, but revisit the design. If there is a processor board and it's required to stay there, and it has some extra I/O, look for any possibility of offloading some hardware functions into firmware. It might be a way also to put a little extra money on your bottom line. So especially older products, this would apply to. A lot of new ones, younger engineers, I doubt you'll find any opportunity here. So looking at the horizon here, there is actually some good news. A lot of fabrication is coming back to the US. So TI, they're building a very large plant up in Utah, and they're, I think, Ogden, if I recall. And also Samsung is building one out in Austin, Texas. And there's many more that are coming back because they see that the supply chain has really hit their bottom line, and they're rethinking outsourcing a lot of this overseas. And lastly here, global risk, something to keep an eye on. I just did a couple screenshots here and cut and paste, and a lot of people are not aware of it. From what I understand, different articles I read, that products consumed in this country, around 60 to 80% the ICs come from Taiwan, from one country. And obviously there's a lot of talk in the news, you hear a lot of threats out there. So if you see something happening, it might be one of those opportunities at 3 in the morning to call your buyer and say, buy everything, because you may not have the opportunity for a long time if you don't. So just pay attention to the news, it's very important. So I'd like to kind of re-summarize here what I just discussed. I know I went through it fairly quickly, but obviously we want to go from when we're looking for parts and addressing these supply chain challenges that we have, we want to go from the easiest solution to getting parts to the most difficult. So obviously, in order, the original parts always the most desirable. It's been tested. We know it works in your design. And the path of least resistance is work with contract manufacturers and see if they can find parts. And you never know. They have access to a lot that is not available from your distributors. And then also look at simplifying, breaking out parts on your BOMs so you can capture every nook and cranny of different variations of the original part. Very important to do. And then also look beyond what you normally use. We're a world economy, so we need to look worldwide for parts, and very important there. And then let's see here. And then we've got fighting substitutions. And obviously, when you have no other choice, you got to go this route. Upgrade or downgrade the grade of components used if possible, and adjust your design to accept different shape of the original and substitution parts. But as we pointed out, use caution in certain parts of that circuit that you don't want to be touching. And as last resort, redesign, and also pertains to new designs, make sure the future designs are more resilient. Now that we've all gone through this very, very painful process, I think we all have a great appreciation and awareness of how to add those little insurance policies in our design to make sure we're not caught and we maximize the possibility of getting parts. Keep that design as simple as possible, and try to use only multi-source ICs when possible. Sometimes it's hard because a lot of those parts, when they're multi-source like that, they're old. And in fact, we only use those in battery chargers. We rarely use them in batteries because the residual current on those ICs are 10, 100 times greater than some of the newer ones. So it's a little difficult to be able to apply it all the time. And then also consider the layouts, as we mentioned quite a few times here, give you component flexibility and prevent any board spins, redesigns, what have you. And then wherever possible, check and use firmware. There's no recurring cost with firmware, and reduce the dependency on sole source parts. So Epic does provide a lot of other products and services. So I'm going to hand this back over to Ed to perhaps cover some of those.
Thanks, Randy. And Randy's going to take a look at the questions that some of you folks may have. As you can see here, we do a lot of other products besides just battery packs. But one of the things that we've been doing, especially with the challenges with components, is spending a lot of time making sure that the timing of our purchases of those components are in line with customer requirements. One of the things that we do with battery pack designs is, as many of you know, it takes an awful long time from the days that you start till you get through certifications and into production. But you can start by developing what's going to be your chipsets and ordering those products now, get them on order for your delivery. Even, some of the TI parts and Seiko parts and other parts have 70-week lead times now. But if you start ordering your volume today, by the time you're ready for production, you have them. And then along with that, we do an awful lot of working with our customers about their forecasting. Unfortunately, right now we're talking about late 2023 and 2024 orders and getting those long lead time parts on order today, because we have to work together to plan through what the demand is going to be. Because while Randy is 100% correct that there is a whole lot more investment being made in IC manufacturing in the US and across the globe, it's not a turn on of a light switch, right? It's going to take some time for it to get there. We have a very good relationship with people like TI and Analog and others, and they're telling us what the timeline is going to be. And from what we're hearing, it's going to be 2023, 2024 before some of these areas. We're even seeing that TI devices are keeping some medical devices from being able to be in production because they just can't get the chips. So we're all in this together. There's a lot that we can do. And as you work with our teams, we're certainly going to be happy to have that discussion with you. So with that, I'll turn it back over to Randy. He can follow up on some of your questions.
All right. Thank you, Ed. Yeah, thanks for sending these questions over to me. I had a little chance to review a couple of them. So as usual, I'll pick the ones I can answer. So right here, one of the questions is why use highly integrated parts to start with if you only get extra bells and whistles? Well, that's, I think, a fair question. And a couple things that come to my mind would be one thing is the highly integrated parts. They do offer less design risk since they've been fully tested, at the factory, at the fab house, and also they're used in thousands of products in different industries. So every one of these parts are used by a lot of other customers, a lot of history on the parts, and so the risk is very, very low that that these parts will misbehave. The other thing I know is, and this even comes back to college days, some of the stuff we studied, but when you get everything on one die, you get better accuracy, better stability. So, these parts have much higher accuracy and better temperature stability, just the fact that they are on a single die. And generally, if you think about it, they require less board real estate, especially if you're looking at redesigns and you're using discrete components. That can actually increase your board size. So they definitely have some real estate option. Also, they can save on pick and place. It's just one IC versus many. The big factor here is also time to market. There's less testing involved because there's a lot of app notes. You have demo boards, what have you. So you're out of the gate really quick with these highly integrated ICs. A good example would be, like a battery charger IC. It offers a very stable DC-DC power conversion over a very wide input temperature, or input voltage range, and also output voltage ranges. And if you use a lot of discrete parts to build these DC-DC converters, sometimes it can be a little difficult to get stability with a very large variance in voltage ranges and also currents. So highly integrated ICs will kind of eliminate all that, and as long as you stay within their expected design parameters and bulk capacitance on the outputs, you're good to go. And also, the charge algorithm, that's also built in. All the LED indicators, that's all built in the one IC. So I still use a lot of them, but the key takeaway here is if you do have to use them, and because you're stuck with real estate, size of product, anything, make sure you stay with a TI or analog / linear type components, because historically I've never had problems getting those parts. ST Thompson I used in the early 90s, so I had a big problem getting parts, and they shut down a project of mine with 52-week lead time. But TI analog, they've never done that to us. So I'm sure once this problem that we have right now in the world is rectified, they'll get back on track and be reliable suppliers. But I still am a firm believer in highly integrated ICs where it makes sense. So let's see, moving on here. Let's see this one here. Okay. Okay, here it says, thanks for the presentation. I noticed that you skimmed over the topic of counterfeit parts. I would like to know how we can be certain that we didn't receive counterfeit parts from a broker. Okay, that one. Okay, well, this one I probably skipped over. I can, to be honest with you, is because I'm still suffering from PTSD on this, from a really bad experience. And this one, it's close to home. It's sometimes just really tough to determine if you got counterfeit parts, and I remember this kind of brings back memories. Quite a while ago, I was working for another company. We had a $3 million recall. That's a lot. Even that's close to 20 years ago, and it was due to something really kind of stupid. It was a 3-amp counterfeit diode, if I recall, and the counterfeiters were pretty clever. The part looked real. It had all the correct markings, right size, even the markings on the reel. It was interesting, and it passed all our production tests, of course, but we started noticing some failures out in the field, and we double checked our design to make sure that we didn't spec in the wrong part or wrong diodes, and that'd be dumb that we overlooked. And we kind of found that everything was looking pretty good, and so we decided to send the parts back to the manufacturer to see why they're failing, and see what they could do or come up with. And we're just expecting maybe a simple X-ray, what have you. But they carefully examined the part, and the factory found that the date codes did not exist in their system. So these counterfeit parts use date codes that they never produced, which was definitely a red flag. And then also the printed logo was slightly different. It was definitely, when you start looking at all the other parts that they produced, it was a slight fade on one side. It was not a legit logo. And then they also decided to examine the part under X-ray, and what they revealed was there's a 1-amp diode die, which is much smaller than the 3-amp die that would be expected in the part. So essentially, the counterfeiters just relabeled 1-amp die, same package as the 3-amp, and passed it on and grabbed some money there. But I don't know, looking back, probably the takeaway here is that, if there's any doubt your parts are counterfeit, honestly, use a reputable broker. Very, very important. But as a minimum, if you suspect anything, just contact the manufacturer, as a minimum, just confirm the dates, date codes, and in our case, the logos on the part before using them. You can send pictures and what have you, and it takes a little time, but it can definitely cost you a massive recall that I personally experienced and still suffer today looking back at it. So anyway, a very good question. I appreciate that one. Okay, looking through here, got a few more here for you. Let me read this one. Okay, how do you know that our design is using a common footprint in its layout? Well, good question. What I do is I kind of use DigiKey, so I kind of cheat here, easy to use. I look at the at the website, and there a lot of times, if I recall correctly, I think it's called was it package or case, something like that. Versus there's a column that might say something the word supplier in it, so it might be supplier device package or what have you. But stay away from anything that says supplier package and stay with the generic, more generic, package case. That is the more industry standard. So when you call out a package or case, make sure you use the generic. Another little thing you can do is you can click on it, and there's a little search, cool little thing you can do. You can click on just that package, and you say find similar parts. If you do the customer one, you'll find only that manufacturer. If you do the more generic one, you'll find a lot of different manufacturers that make that same part. So that's also a good indicator on how you can kind of see if you're using the right pads on your board layout. So let's see here. Let's see, this one here says, can you please go in a little more detail on what variables need to be considered when using scrap parts? Okay, yeah, I agree. I just barely touched on that. There are a number of factors that need to be considered. Though, has the part actually been used, or is it just a part of the manufacturing fallout for reasons other than the part itself? If the part hasn't been used and the part is kind of large with minimal solder connections to the board, the risk is very, very low in reusing that part. It's easy to resolder or desolder, then resolder, minimal whispering on the part. So you'd have a low risk there. But if you look at maybe the other extreme would be if the part came from a return scrap and it's heavily used, let's say it's in a high temperature power supply portion of the circuit, where the part is very complex with dozens of fine pitch solder connections, or maybe a leadless package might come to mind here. There, the risk could be a little higher for either a part failure because it's worn out, or perhaps assembly failure because there's so many connections or buried connections, and you don't have those really nice little perfect solder balls on the bottom of the part. Those are gone. So you might have some risk there of being able to regulate how much solder is on your board. So those are things that you really want to look at. But all these variables, of course, need to be factored in, before using the part. But yeah, good question. That one, you just got to work closely with your manufacturing team, and they'll let you know if it'll be reliable to reuse. So I think here, yeah, we're coming up here on time. So we got another question. We've got a few more, but as Ed mentioned, we'll definitely answer all the questions via email after I do this one, and really appreciate all these questions. But here we got, okay, yeah, this is actually good. Wouldn't firmware have already been used instead of hardware? However, just whenever it was possible to keep the cost low anyway. Yeah, I totally agree. It should be. Good design reviews that would be uncovered. But it should. But you got to keep in mind, a lot of the customers, we work with on new projects, and also we work with a lot of customers that are retrofitting new chemistries into old products. So we see some of this, and some of the products that have been around, for a while, definitely have not taken advantage of the ever-increasing functionality of the newer controllers. There could be some arcade parts in there that that just wasn't available back in those days. And you know, a good example of this, I remember back in, Ed did say I was started this in '96 on batteries, but I remember, you know, back with some of the very first battery chargers we did off the line, uh, battery chargers, the PIC controllers, I've always been a big fan of PICs, but back in those days, PICs, I know the young engineers won't believe me in a million years, but the young, you know, the old PICs only had 8-bit A to D. That was the technology. That was state of the art, 8 bits. Now, you know, 16, whatever, and higher. So, and I had to use an external TI, I2C, 10-bit A to D, and bring that in and write code to our PIC controller just to get the resolution of the battery voltage we needed to properly regulate this battery charger. It was just kind of crazy. So, and so what's really kind of funny is I was talking to a customer the other day, and they're actually still producing this product today. And how long has it been? You know, surprised they can still get parts. Maybe they can get parts easily since they're so old, right? But you know, if that product were to you know, redesigned, you know, today, obviously that TI I2C part would just be removed and thrown away, and a newer PIC would be selected, and all that functionality would be embedded in code. So there are opportunities there to eliminate parts. And the takeaway here, I imagine, is, you know, some of the old designs, to an engineer's defense, the old days they didn't have those options. Nowadays there's a lot more. So, but definitely look back at your designs, whatever age they are. But there's always opportunity, something not to dismiss. So anyway, you know, probably enough of that. And I want to definitely get those questions in. We'll be happy to answer them as we mentioned. And I want to thank everybody for joining us. Tough times, trying to find parts, and just want to wish everybody happy part hunting. So anyway, with that, I want to thank everybody, and everybody have a wonderful weekend. Thank you.